So in this demo, I will present end-to-end MLOps pipeline for predicting heart disease risk using the UCI Heart Disease datasets. The objective of this assignment is to demonstrate a production-ready machine learning workflow covering data preparation, model training, experiment tracking, CI/CD automation, containerization, and monitoring deployment. So I will walk you through what exactly the GitHub repository which we have maintained for this. So this is the GitHub repository where we are exactly where we have actually all the codes artifacts for this project are maintained in this repository, which actually having the structured folder for data processing, model training, then API solvings, then we have a test, then CI/CD, where we are exactly maintaining through the Git workflows here, and Docker configuration. Then we have a multiple documentation present here. So this basically ensure version control, collaboration, and full reproducibility of an entire ML pipeline. So the next which I will be walking through is the exploratory data analysis which we have done it. So the data set which was obtained from the provided UCI machine learning repository during the exploratory data analysis, we examined missing values, feature distributions, and class balance to assess data quality and potential imbalance. So we have taken help of professional visualization such as histograms, um, then correlation heat maps uh, were used to basically understand the relationship between clinical features. So in the train.py, so after the pre-processing, features and target variables were separated and numerical features were scaled where required. Uh, so two classification models we were trained, basically the logistic regression and random forest. So here the model performance was evaluated using the accuracy and ROC AUC metrics to ensure objective comparison. So so in the next part, basically we are covering the experiment tracking with MLflow UI. So if I go to the MLflow UI, so there are multiple experiments has been tracked here. So whenever the number of times a user trains the model, the respective artifacts or the details will be get tracked under this MLflow UI. So like example, I want to select a best mm, artifact, or we want to compare the different models here. So we can see here the comparison. So these are the run which has taken place, the time, the start date and date, the duration. These are the accuracy scores of each of this model here. Like for example, random forest, we have a 0.883. Same way for logistic regression, which has been ran on this date, having the accuracy of 0.867. So comparatively, we can check for other models on the basis of what we have trained the model. So this is all about the MLflow UI. Then I will go to the main.py file and the Swagger UI explanation, where exactly, yeah, this is main.py file. So the selected model, like the earlier what I have said, the two models has been selected. So and the pre-processing scalar were saved here for the package for inference. So here you can see this is the scalar model and scalar has been packaged here in the .pkl file. So basically this system will save the best input here, like example here. It will only save the pkl file wherever it will get the best scores or the accuracy. So same way we have exposes API also, the Swagger API, which will which is basically a fast API based REST API, which accept the patient data. So this is the patient data, and it will in return provide the prediction and confidence score. Like for one of our patient data, it is throwing that the prediction is 1 and confidence is 0.52. It represents that patient is having heart disease and confidence is 52%. So if a patient get a 0, then the patient doesn't have a heart disease. So The next which I will be explaining is the containerization and deployment. So in the Docker file, uh, this Docker file, the application is containerized using the Docker to ensure environment consistency. The Docker image bundle the API and trained model and dependencies enabling reproducible deployment. Same way, we have taken help of Docker Desktop to deploy it locally, which is basically simulating a production environment setup. Now I will go and explain the monitoring and logging. So, so the application level logging was implemented using the Python logging module. So each API request logs timestamp, uh, input payloads, what we will be sending it from the Swagger UI, and predictions. Like here you can see the prediction and confidence score, and confidence score will be, yeah, in this logs we'll be able to get the logger details. Basically the application level logger details will be able to find it here. Same way for basic monitoring, um, so we have created another API using the Prometheus implementation or instrumentation, where we'll be getting all the endpoint request count, like how many times the endpoint has been triggered, then latency, system level matrices. We'll able to find it here in this response body. Now I will jump into the CI/CD pipeline which we have created. So the action, if you go here, so we can see the multiple CI/CD pipeline has been triggered. So we have tested both positive and negative scenarios. So in the positive scenarios, I will walk you through that, which has been triggered successfully, and it has went through all the required steps here. Like the first is setup job, checkout repository, Python setup, install dependencies, run the unit test, setup Python, then checkout, then complete job. So it has been successfully went through all the steps, and you can see for each of the step it will capture the logs, required logs, how exactly the unit testing has been done. So this we have implemented. And same way, we have also tested one failure scenario where exactly we have changed some coding error. We have implemented some coding error, and automatically the CI/CD pipeline got failed with this required error. So this is all about the CI/CD pipeline. So basically, the overall assignment demonstrates a complete MLOps lifecycle for data from data ingestion to monitored deployment and aligned with the real world production with the best practices also we have considered in our assignment. So the complete the source code, CI/CD workflows and documentation are available in the link GitHub repository present here. So this is all about the assignment which we have completed. Thank you.